I'm Sandhya, Assistant Professor, Department of Mathematics in SNS College of Technology. Today we are going to discuss about the design thinking concept in matrices in canonical form. So, in this design thinking concept in canonical form, we are going to discuss about these 5 steps. So, in these 5 steps are introduction to design thinking, the power of mathematical matrix and design thinking and matrices, applications in engineering mathematics, and key takeaways and next steps. So, before that, we are going to discuss about what is design thinking. All of you know, design thinking is a human-centered, iterative problem-solving technology. So, it is understanding the user needs to create innovative, effective solutions. It is widely used in engineering to foster creativity and optimize complex systems. All of you know what are the steps involving the design thinking. So here there are 5 stages are there. So first one is empathize, second one is define, third one is ideate, fourth one is prototype, and fifth one is testing. So next we are going to discuss about the empathy first. So in this foundation of innovation, in design thinking empathize, deeply understanding the end user challenges, needs and desire. This observation user behaviors, conducting the interviews and surveys. The user environmental, the first step ensure that the solution are truly relevant and impactful. So in this assumption and addressing real world problems. So next we are move on to why combine design thinking with mathematical matrices. In this, engineering problems often require structured logical framework. Matrices in canonical form, it is simplifying complex system for the analysis of design thinking adds creativity and user focus, the mathematical, creating a powerful scenario. So in this bridging the gap system optimization. So in these 2 cases we are used to the design thinking in the mathematical concept. So next one is the power of canonical forms in engineering. So in this power of canonical form engineering is Jordan canonical form. It is the matrix representation for the system with repeated eigenvalues for the crucial for analyzing the system stability. It is the dynamic behavior in control system. So it is the Jordan canonical form. It is mainly analyzing the system stability. So in this Jordan canonical form, mainly analyzing in the what is that? The analyzing the system stability and dynamic behavior. So next one is what is the diagonal form. So in this diagonal form, when a matrix can be diagonalized, enabling the straightforward computation of a matrix powers and understanding the system modes. So here we are going to using the signal processing and the vibrating analysis. So in the signal processing and vibrating analysis mainly used in the ECE streams and triple E. So here the signal processing and vibration analysis, the diagonal form of the matrices are used rapidly. So next one is what is that? the row echelon form. In this row echelon form, it is a solving system of linear equations determining the rank and the identifying basic vectors fundamental in structural analysis and network flow problems. In this, network flow problems are mainly used in the numerical problems. In this, numerical problems are mainly useful to the non-circuit branches. Students are rapidly used in the networking flow problems, and also used to the circuit students also. So it is the power of canonical form in the engineering. So next one is the understanding that is matrix in the canonical form. In the canonical form are standardized matrix representation that reveal the fundamental properties of the system, simplifying analysis and computation. So here we are going to solving the system of linear equation more efficiently. So here analyzing the stability and behavior of the dynamic problems. So here in this dynamic problem, they are used in the solving the linear and non-linear equation, and also performing the transformation in computer graphics and robotics. So mainly matters are used to computer graphics and robotics. By reducing matters to their unique forms, engineers can extract the critical information and make informed the designing decisions. So next one is applying design thinking to matrices based engineering problems. So first we are going to discuss about the empathy and define. It is understanding the real world engineering constraints and user needs for the system that is by the matrix. Here the constraints and user need for the system by the matrices. Next one is ideate. So in this ideate, the brainstorms novel solutions and transformation within the mathematical framework. So next one is prototype. To develop simplified the mathematical models are simultaneous using the canonical form. Next type is that is the stage is testing. So here it is validate the mathematical models output against the real world performance and user feedbacks. Next one is the role of matrices in engineering designs are providing a language for modeling, analyzing the optimizing complex. In this optimized complex, that is OR, commonly used in the role of the matrices in engineering. So it is modeling system behaviors representing the physical phenomena, electrical circuit and that is the mechanical structure as system of linear equations. Next one is constraint management. In this constraint management, encoding the designing limitation and operational boundaries for the optimal resources allocation and performance. So in this constraint management, we are allocating and performance for the optimal resources. So here next one is the decision making, that is the structured data representation for informed choice in designing iteration and material selection. So here integrating to control system matters enable engineering to predict outcomes and refine the designs before the physical prototyping. So in this the engineering commonly used in the matrices in this way. So next we are moving on the key takeaways and what is the next steps in this human centered math. So here the design thinking enriches So designing math with empathy. So here we leading more user friendly and effective solutions. Next one is the canonical simplification. In this canonical simplification are powerful tools for the simplifying complex system and revealing their what is the core properties. So here we are going to discuss about the revealing their core properties. Thank you.